next one is the session layer. Okay, the first application of first work of session layer is dialog control. Dialog control allows two systems to enter into a dialogue. The two systems want to communicate continuously, means the data transmission has to be done in both sides. The dialogue has to be maintained. The communication between two processes take place in either half duplex, that means the data transmission can be done from one side at a time, or it may be a full duplex. That is, data transmission can be done from both sides at a time. The next job is token management. In token management, the session layer provides tokens that can be exchanged between two computers on the network. The computer which holds the token can perform the operation at that times. Okay, if two computers want to communicate, for which the computers which is having a token can communicate. For that one, some protocols are already set in the session layer. The session layer inserts checkpoints. Okay, what is the meaning of checkpoints? If you want to send some, for example, if you are downloading a book of 100 pages, that means for each page is downloading at a time. Now, after every 10 page, we put one checkpoints. Here, after every page download, the sender will send, the receiver will send an acknowledgement to the sender. Okay, imagine after 25 pages, the system crash. After 25 pages, the system crash. If the session is or synchronization is not maintained, what happens? Entire 20 page has to be sent again. But after every 10 page, a checkpoint is maintained. So after 20, a checkpoint is already there. So only 21 to 25 pages, that page has to be resent. So the data transmission is done or reduced with the help of session layer. The network component gateway is actually a part of this layer, that is session layer. The protocols that work on this layer is called as Net BIOS protocol. The next one is the presentation layer. The job of presentation layer is translation, encryption, and compression. What is the meaning of translation actually? When you are sending some data in the form of character string or numbers, the sender encoding technique of that character or number is different than receiver encoding technique. In that case, the session layer converts the data into a encoding technique called as common form, and that common form of data is sent it to the destination. At the destination, the presentation layer converts the common form of data into encoding technique used by the receiver and receive it. So that is called as translation. Translation means the encoding technique used by sender to encoding technique used by the receiver. Okay, the data is transmitted between them. Okay, it is called as translation. The next one is called as encryption. In the encryption technique, mostly it is used for security purpose. When the data is sent, it is a normal text maybe sometime. So it is converted into non-readable format, that is called as cipher text, and that can be performed by a technique called as encoding. When the encoded data is sent to the receiver converts back into normal data. That is the technique called as decoding. That is actually done by presentation layer. Encryption is data is converted into ciphertext, and ciphertext is given to the destination, converted back to normal data. The last one is called as compression. In the compression technique, the data is compressed to a shorter format. For example, if you have a 10 KB of data, the same data can be compressed to a 2 KB of data and transmitted to the destination. Here it is decompressed back to 10 KB of data. So the data transmission done is less, so the speed is increased. Most of the audio and videos data transmission is done by using compression technology. Okay, this is the work of presentation layer. Next one is called the application layer. This application layer helps the application to access the network resources. It also helps in establishing a network connection and data transfer service from one user to the another users. It provides a network service such as file transfer, email, or web page access. Such services are provided by the application layer. The application layer can be divided as network applications, standalone applications, embedded applications, etc. Some of the gateways are actually designed, network gateways are actually designed based on application layer. And the protocols which is used in application layers are FTTP, Telnet, SMTP, HTTP, AppleTalk, SNMP, etc. The second model is called as TCP/IP model. In TCP/IP model, there are 4 layers. There are application layer, transport layer, internet layer, and network interface card. When you compare this TCP/IP model with OSI model, it is look like this way. Application layer is similar to application presentation and session layer, whereas transportation layer and internet layers are really related to transport and network layer. And network interface means it's just like a data link and physical layers. This job is actually done by data link layer, and physical layer job is done by network interface layer. Now we will learn here the application of each layer in the TCP/IP one by one. The first one is called as application layer. This layer provides the services which is helpful for the user applications. If user application want to connect to the network, then this application layer has been used. The application layer provides some high-level protocols such as FTP, Telnet, HTTP, SMTP, etc. These are the protocols are provided to deliver the data over a network. And the next protocol is actually called as transport layer. The transport layer is responsible for the reliable data transfer between source computer to the destination computer. Just like here, transport layer in the OSI model. This transport layer provides two protocols. One is called as TCP. The second one is called as UDP. The first one is called as, yeah, these are the diagrams shows. Okay, now the application layers actually provides these number of different protocols, and transport layer provides TCP and UDP. Okay, these are the main protocols of transport layer. This TCP layer is actually called as connection oriented protocol. TCP layer is called as connection oriented protocol. The connection oriented protocol means before delivering the packets, first it will establish a virtual connection between source and destination. All the packets are transmitted from source in the same path to the destination. So these type of connections, the protocols are called as reliable protocols, because there is a confirmation that the packets are received at the destination properly. And the second one is called as UDP protocol, which is called as connectionless protocol. In connectionless protocol, the data is, there is no any virtual path between source and destination. The data is added with address, source and destination address, and send it to the destination in the form of packets. The packets are travel from one router to the another router, different routers, and reach the destination. These type of networks, protocols are not reliable one, because there is no confirmation that all the packets are received at the destination properly. The next layer is called as internet layer. This internet layer is same as network layer, which provides a connection across network and ensure that there is a transfer of data between the source to the destination computer successful. Okay, here just like here, one packet is created and send it to the destination, check it whether it's received successful or not. This layer is also responsible for locating the shortest path or route from source to the destination. If many routes are available, it will find out the shortest one. Some of the protocols which is used in the internet are actually, internet layer is actually IP. This is the main protocol we use in the network layer. This IP, two protocols are there, mainly Internet Protocol and Internet Control Message Protocol, that is ICMP. Okay, these protocols are not reliable. There is no guarantee that the data transmitted by these protocols are received here at the destination. Okay, the next one is called as network access layer. In this layer, the source computer connects with the destination computer using protocols such as Ethernet, token ring, etc. This layer also contains network devices that are attached to the network. Every data packet moves through this layer before it goes out through a transmission medium to the destination computer. This network layer is actually this network interface layer is actually data link layer and physical layer of the OSI model. Next one is the difference between OSI reference model and TCP/IP model. In OSI model is actually generic and protocol independent standard, whereas TCP/IP model is based on standard protocol around which the internet was developed. In OSI model, the transport layer guarantees the delivery of packets. That means packets are delivered at appropriately. That is indicated by OSI model. In TCP/IP model, the transport layer does not guarantee the delivery of packets. Whereas in the OSI model, it follows a vertical approach, and TCP/IP model, it follows a horizontal approach. OSI model has a separate presentation layer and session layer, but in TCP/IP, it does not have a presentation as well as session layer. Transport layer is a connection oriented. In OSI model, transport layer is a connection oriented. In TCP/IP model, the transport layer is both connection oriented and connectionless. Both type of connection is there. In OSI model, network layer is both connection oriented and connectionless. But in TCP/IP model, network layer is only connectionless. Generally, OSI model is used as a guidelines or a guidance to develop other models. In a real practical, there is no OSI model is implementation. But TCP/IP model is actually a implementation of OSI model. It is actually, this model is actually used for internet, but there is no any real life application in which the OSI model is developed. Network layer of OSI model provides both connection oriented and connectionless service. But in network layer, in TCP/IP model provide connection less service. OSI model has the problem of fitting the protocol into the model. But in TCP/IP model does not fit any protocol. In OSI model, protocols are hidden in OSI model and easily replaced as the technology changes. In TCP/IP, replacing protocol is not easy. OSI model defines services, interfaces, and protocols very clearly and makes clear distinction between them. In TCP/IP services, interfaces and protocols are not clearly separated. It is a protocol independent. OSI model is a protocol independent, whereas TCP/IP is a protocol dependent. OSI model has 7 layers and TCP/IP has 4 layers.